The purpose of this lab is to introduce you to the software Stellarium, an open source planetarium program available for free download at this address. Stellarium is a powerful observatory using a computer-generated sky. It is more advantageous than using a conventional telescope because it is never too cloudy to observe the sky on the screen. We can examine the sky on any day, any time, and from anywhere. In the first part of this lab, I described the two systems of coordinates used to locate an object on the celestial sphere. The horizon system, where we use the altitude and azimuth to locate an object, and the equatorial system, where we use the right ascension measured in hours, minutes, and seconds, and the declination measured in degrees to locate the position of an object on the celestial sphere. The objective of this part is to familiarize with the Stellarium program and use it to examine the position of the Sun in the sky over the course of a year. To begin with, launch the Stellarium program. It will open like this with a grassy background, and you can make it full screen. Let me first of all locate where I have the full screen. You see there's a toolbar here which lets you do a lot of things. So that is the full screen. Now make it full screen, and now let's get used to the toolbar. If you bring your mouse over to the corner here, you see a toolbar opening up vertically and another one horizontally. All right, let's start with the vertical one. The top is the location window. Click on that and choose the location. Now the Stellarium software opens with the default location where you are located. It automatically opens at that place. You can actually change it by maybe typing it here, or there are a number of places listed in the location chart. You can choose any of these places. For example, if you want to go to Portugal and observe it from there, click there and you have the sky there. And you can always return to the default location this way. All right, so first choose your location and close the location window. Now here, once you have the screen, by using your mouse you can move it. Look at that, I'm holding the mouse and holding it and moving it down and moving it up and to the right and left. And also if I click on the right, I can move it and maneuver the image anywhere I want. All right, let's go back to the toolbar, and the second item is the Datetime window. Click on that and automatically it gives you today's date and the present time. Now today for me is 11th December 2016. Look at the way the date is entered. 2016 December 11th. So obviously this software is not made in the United States. And the time is 13 hours, 25 minutes and 14 seconds. Now you can change these. This is the present time and you can see the sun is right here. And when I look out of the window, I can see the sun right there. So it is correct. We are actually looking at the present situation on the sky. Now what will the sky look like an hour from now? That's how it will look. Well, an hour before. You will increase it on the top. An hour, this is the present time. An hour from now, the sun will be there. Another hour, the sun will be there, and I can move this out to watch the sun again. And at 4 o'clock, the sun will be there. And at 5 o'clock, there it is already set. And if you want to find the exact time for the setting sun, you can manipulate here. You can click on the minutes there, and you need to play with that and see where you can find the position of the sun when it is beginning to set. You can see it's happening here. This is almost a sunset time. You can change the hour, minutes, and second. Also, you can change the date or change the year. You can actually go back in time and look at the sky when it was like 10 years ago. All right, so we have done with the two items. Once you have selected the time and the location, let's go back to the present time. That is, what is the present time? I'm nearly 1 o'clock here, I think. Well, that is about 2 o'clock local time. All right, I'm going to close it. Now, what else do we have? We have sky viewing options. We have a search. If you are looking for a particular object, you can search from here. We will work with that later. And configuration, you can change all the configurations you want. And the help window. And what have you got on the horizontal toolbar is the, you can see when I put the mouse on top, it describes over here. You see that? It says constellation lines. If I click on it, then all the constellations are marked for you. And the second, constellation labels, I can label all the constellations. So our sun now is in the constellation Scorpius. All right, if you don't want them, click on them again. The drawings are gone and the names are gone. All right. Now, if you want the equatorial grid, we talked about the equatorial and the horizon system. If you want the equatorial grid, you click on it, and now you have the two coordinates. What are the two coordinates we use in the equatorial? It's the right ascension. Where is the starting point? Well, the starting point is the vernal equinox. You can see 17 hours, 18 hours, and so on. That is the right ascension, and this is the declination. Now, what is the declination of the sun? You can actually see it's approximately -23. What does the negative sign means? It means that the sun is now below the celestial equator. Is that right? We are nearing the winter solstice, when the sun will be directly over the Tropic of Capricorn. Is that right? Okay, so that's the equatorial, and if you don't want that, you can click on it again. That will go away. And if you want the horizon, we have the azimuthal, that is the altitude azimuth system here. So you can choose that if you want. Another one, if you want, now at the moment the atmosphere is there. If you don't want the atmosphere and want to view it directly without the interference of the atmosphere, let's come over here and click on it, and you can see all the stars are now visible. You can see Venus there, Mercury there, Saturn there. You can see all the planets, Mars, Venus, Mercury, all planets are there, and the sun is right there. Okay, let's take away that. Where did we go? Over here, the atmosphere. Click again. There you go. And let's take away the grids, the azimuthal grids. Okay, what do you have next? Now, this toolbar actually helps you to switch between equatorial and azimuthal mount. And this one helps you to center on a selected object. If you select one object like Mars or Venus, and that will center, the picture will center on that object. And this will toggle back and forth, full screen. Well, let's get back on the full screen there. There we go. And there are more in here. You have, well, let's get some of these. This will decrease time speed. That will set normal time. And that will set time to now, and so on. And if you want to exit the program, that is where it is. Now, what I would like you to do is play with it for a while. Now, let's get back on to take the, well, let's get back the time, date again. Go back to the date and time. Let's advance and see what happens as time goes on. That will be, well, 3 o'clock, 4 o'clock, 5 o'clock. That's about 6 o'clock. All right, you can see Venus is going down, and you can move in any direction you want. You can see the moon is right there. That's the moon. All right, you can move in any direction you want by holding on to the mouse, to the up and down, to the side. Okay. Now, if you click on any of these, let's click on, let's say, the moon. Now, you get all information you want about the moon here. It gives you its right ascension and declination. The right ascension is some hours and minutes and seconds. Its declination is 13 degrees, 13 arc minutes, 3.7 arc seconds. That is the equatorial system. And if you come to the horizontal system, it gives you the azimuth altitude. The azimuth is 95 degrees, 55 minutes, and so on. The altitude is 41 degrees. I hope now you understand all these. If you haven't watched the part of this lab where I describe the coordinates, please watch that. Only when you understand what they are, you will appreciate this better. All right, you can change the object. If you now change to Mars, you get all the details on Mars here. All right, now let's get back on the equatorial grid. Now, if you move on, you can actually look at the zenith. Well, it moves back and forth. That's why I said try and play with it. But you can see the moon. What is the, let's look at the moon again. What is the declination of, what is the azimuthal? The altitude is 41 degrees and the azimuth is 96 degrees. So if you want to go to the zenith, you got to go all the way up there. Okay, let's go back to the location. We can go to, say, Cowley, United Kingdom, and see how the, well, this is the time that we have set. If you want to go back to, let's get out of here and get the time. Well, the time now is about 7 o'clock there, is that right? And if you look, you can see the zenith almost there. That is, yes. So the sky above this particular place, which is Cowley, England, looks like this. You can see the moon there. Now, if you want to let somebody have a look at a celestial object, which coordinate would you use? Is it the horizon coordinate system or the equatorial coordinate system? Now remember, the horizon coordinate system keeps changing from place to place because of the rotation of the Earth, whereas the equatorial system does not change. So if you want to let somebody in England look at a particular object, you've got to give him or her the equatorial coordinates. All right, what I would like you to do is play with this. We have several labs based on this, and I will not be describing this each time. You must be familiar with this software. I will be giving you specific directions on what to do in each of the labs. Let's now go back to the default location, which is Port Charlotte, Florida, and take a look at the sun and see the journey of the sun for the next 1 year around the sun. Now, today we are December 11th, 2016 at 11 o'clock. Is that right? Now, choose the sun by clicking on it. When you click on an object, the description of that object comes here. Now, you got the right ascension, 17 hour, 15 minutes, 48.53 seconds. The declination is negative 23 degrees, 3 minutes, 1.6 seconds, and so on. Now, let's advance by 3 months, right? That will be January 2017, February 2017, and that will be March 2017. Let's see, on March 21st, let's go to 21st, all right? Where is the sun on March 21st? Now, what is the significance of that day? On March 21st, the path of the sun will intersect the celestial equator, that is the vernal equinox. What do you expect the declination of sun to be that day? Well, you can see right ascension is 0 hour 0. In other words, right ascension is measured from vernal equinox. So this is almost 0, 0, 0. You can adjust it to 0 by changing the time in here, by the seconds and minutes. It's not exact here. And the declination is also 0. That is the vernal equinox. Now, let's advance to April, May, June. June 21st is the summer solstice, and you can see the sun is now the northernmost, 23.5 degrees, the northernmost, and it's right ascension is 6 hours 1 minute and so on. Now what I want you to do is locate the coordinates of the sun at each of these. Go to September 21st, December 21st, and so on, and complete the table for the sun. And now do the same for the moon as well. So you will complete 2 tables, one for the sun and one for the moon. All right, that's it for now for this lab.